Okay, so this is a tutorial on how to analyze some really basic data. You're going to take an average standard deviation calculation, and you're also going to calculate a 95% confidence interval. So this is my data table. I've just collected some really basic data. This is the foot length and the height of a class and the gender according to each of those students. What I'd like to do is find out the average height of all the men and all the average height of all the women, and as well as the average, I'd like to know the standard deviation and the 95% confidence interval. So let's get started. When I'm calculating average in LibreOffice, first put in equal sign, and I'm going to type average. And then I open the parentheses. Now here it's telling me what information I need to give it. If you're ever lost, always look at these hints as far as what you need to do next. Then I'm just going to select the data that I want to take an average of. And as this is for the male participants, I'm going to select all these height data and hit enter. And that'll give me my average. Now keep in mind, sometimes you will get 5 or 8 or 10 or more decimal points based on this calculation. If I click on here, I can right-click, format that cell, and dictate or tell the computer how many decimal places I'd like to have. That's, of course, going to depend on what my measurement uncertainty is. That needs to reflect the measurement uncertainty, which you can see is reported in my table the way it needs to always be reported in a table, especially for the IB, with the plus or minus measurement uncertainty and the units of that measurement. In this case, 1 decimal place, and that reflects my data. Okay, so that's all right. I want to do the same thing for the female participants is equal to average, open parentheses, and then I select the relevant cells and hit enter. Okay, so it looks like there's a difference here, but again, whenever there's an average, there's also going to be some spread in the data. You can see there's some low numbers and some high numbers. And the standard deviation is going to give us a feel for that spread in the data. Here's how you calculate it. Is equal to STDEV, standard deviation, open parentheses. And again, I just choose the numbers that are included in the average that I calculated. You do the same thing for the women. Okay. Those are my calculations. Now keep in mind, the standard deviation needs to also have the same level of precision as the measurement. So I don't want to have extra decimal places showing up here. I also don't want to have any fewer. I need to have the same number of decimal places or the same level of precision here. Okay, so what this is showing me is there's a slightly lower average amongst the female participants as far as their height, but a slightly higher standard deviation, so a little bit more variance in that data. Another good way to report this kind of information is with a 95% confidence interval, which is going to give me a range of values, probably centered around here, not just probably, it is centered around the average, where I'm 95% sure to capture the quote-unquote true value, or the population mean. So let's go ahead and calculate this. First thing we need to do is we need to calculate a statistic that is based on the standard deviation and the sampled size, and that is called confidence. So it's asking for an alpha value, and the alpha value is just the opposite of this 95%. So the alpha is the 5%, and we're going to put in 0.05. Now, if you're doing a 99% confidence interval, you want to be 99% sure to capture the true value, you'd use an alpha of 0.01. For our intents and purposes in biology, a 0.05 alpha level is standard, and that's what we're going to use. Then it wants to know what the standard deviation is, and I can just point it to this cell since I've already calculated that. And the size is not the size, the average here, but it's the size of the data set, how many pieces of data you have. And here I happen to have measured 9 individuals. And that gives me the value that I'm going to subtract and add to this number to give me a range of numbers for my confidence interval. So let's go ahead and do that. This is equal to the average minus this statistic, and this is equal to the average plus this statistic. So I can be 95% sure that the true mean of the male population, let's say these are year 6 students, is going to be somewhere between 162.1 centimeters and 168.6 centimeters. And I can do the same thing then for the female population. First I need to go and calculate this number. And I'm going to take a shortcut here by copying the formula. And then I just need to go in and change the number. I happen to have 10 female participants. But you can see that LibreOffice, just like Excel, is smart enough to know that I'm referring to this standard deviation number, the F4 cell. And the alpha stays the same. So this is my calculated value. And here, I'm going to grab this little bottom right corner and drag it down. And what that's done is it's copied the formula and said, I want this cell minus this cell. And that gives me this value. I can do the same thing here. Now, whenever you do something like that, you always have to double check that your program was smart enough to put in the values you were expecting it to put in to make sure it's doing the right thing. But in this case, it worked out. So now I know that my confidence interval for the population of year 6 female students, their average height is going to actually be somewhere between 156.3 and 163.7 centimeters. And I can say that I know the true value lies somewhere between here with 95% confidence. I'm 95% sure. Okay, well, let's say we wanted to find out if there's a statistically significant difference between these two populations, the men and the women of year 6. Well, we can tell that there is some difference. There's about a little more than a 5 centimeter difference in our measurement. We can also see that given the two population estimates, so this is for the actual people that I've measured, the people in classroom that I've actually had stand next to a yardstick or meter stick, and this is my estimate then for the rest of the population of those people. And you can see that they overlap slightly. Here, the lowest value overlaps with this value. So how can I do a test to find out if these are statistically significantly different? It means they're different enough that the likelihood that these data sets are coming from the same pool is very, very low. We're going to do what's called, as you may have guessed, a t-test. And to do that, we put in the formula equals t dot test, open parentheses. And then I need to put in my two sets of data, data 1, comma, and second data set, data 2. Then it wants the mode, and it's giving me some information about this. This is a one-tailed or two-tailed distribution. Basically, this is asking if we already know what direction they might be different in. If you're not sure, always put in 2. And the type of t-test. This is something that has to do with how you're measuring variance. It's not something you need to worry about. We're just going to put in type 2 and enter. Okay, and then it spits out this small number, 0.048. This is the p-value of our t-test. So this is the probability that these two measurements have no real-world difference. So the likelihood that the difference we're seeing here is not due to some real-world difference, but just to random chance, is 4.8%. And in our case, we're going to say whenever the p-value is below 5%, or 0.05, we're going to reject the null hypothesis and conclude that there is a statistically significant difference. which there happens to be in this case. It's close, but there is one. Okay, so I'm going to label that. This is the p-value of 0.48. Okay, that should have given you some insight about doing average, standard deviation, confidence interval, and t-test calculations in LibreOffice.